Hey, welcome to this Python Advanced Concept session. Today's session 1. My name is Untitled, and I'll be taking over um, some sessions today and the next 3 days. Today is day 1. We'll be covering comprehension concepts in Python today. This session is for people who have already have an intermediate level of Python understanding. And you should, if you want to understand more advanced concepts, I'll try to cover it here. I'll also at the end of this give some information about the lead code problems that can be solved using these comprehension, so you can look at those and refer those. Let's dive in. A little bit about myself. I'm Anand Thirumanur. I have a lot of experience with respect to data related programs. I work in the information management data engineering space. I've been working with the analytics and visualization, data flow, data integrity, data automation, and data science. We'll cover 5 Python concepts from Jan 4th until Jan 9th. We'll cover Lambda functions, comprehensions, generators, decorators, and hashability. With respect to my experience, I have 3+ years of AWS and GCP experience. I have thought leadership in information management practice, so a lot of data expertise. With respect to Python, I've built data engineering pipelines using Python for over 5 years. Today, there are some topics that we're covering. First one is comprehensions. In the next few sessions, we'll cover Lambda functions, and then we'll go on to take up generators. After generators, we'll work on decorators, and the last topic we'll cover in this advanced session is hashability. As always, find us on YouTube, subscribe to the channel, hit the like button if you get any benefit from this. Let's start with today's topic, list comprehension. We're not only covering list comprehension, we're also covering like sets, dictionaries, and generators. But I'll start with list comprehension because that's the easiest part to start with. Like with your knowledge, you already know what a list is, and you probably know what list comprehension is. But let me cover it a little bit. What Wikipedia says is it defines list comprehension as a syntactic construct, that is a way where you can syntactically write a statement, which is available in some programming language, and here it's available in Python. That's why we're covering it, and it's used for creating a list based on existing lists. So when you already have a list as an input and you want to do something with that list and then create another list which is probably of the same size, sometimes smaller, then we can use this list comprehension. It's a shorthand way of creating a new list. Say I'm given a list of integers 1, 11, 14, 15, 7, 2, 3. Say I want to create a new list which is multiplied, where you want to multiply each of them by 2. Then you write one statement here. You create something called a new list, and then within your square brackets you give in your syntactic statement, to Python, this shows that this new list is going to be a list, and how to construct that list is provided in this logic here. And in this logic, what we do is we provide the value that we need to get out here, and for each of these values it goes through a for loop, and the for loop goes through the input list. So the input list here is nums, and what we're doing is we're doing a for loop. We're picking each element in nums, and then we're doing some processing here. Here we're multiplying it by 2. We could say we could square each number, or you could do other things, and then we print the new and then we get this list of so from this list we get a new list, and that's what we store in here. So let's try this. So what we get here is the first number square is 1, the second number 11 square is 121, the third number 14 square is 196, and so on until the last number 9. Say if you don't want to like square it for certain conditions, then you can put in a condition here, and you can say if x, say you want to square only the ones which are odd, so you can actually put in a modulus 2 and say is not equal to 0. This will mean only the so here there are 7 elements in this list, but you only want the ones that are odd to come out as squared. So you want to eliminate this number and this number, so you would come out with 5 numbers. So this if condition is essentially filtering out only the ones we want. So we only want the odd number, so it's filtering it out, and then you'll have a smaller list come out of that. So if you run that, if you see this has only 5 elements, it's missing the 14 square and the 2 square. Everything else comes out here. That's a way where you can actually put in a condition and only filter certain things. You could also put in a if condition here. So you can say if x is greater than 10, then it can just provide x, else it can do an else, else it can do so you can provide it to provide different values based on if you want that to be provided here or not. So based on that you can provide that. So if you want the condition to be on the left side, you can do that as well. Let's come back to that. When you get to interviews, they will ask you questions as to, okay, you want to use a list comprehension. Why can't you just do this using a for loop? Yes, this can be done using a for loop. So for example, if you wanted to do if you want to take the input list and you want to do something to the input list and make that into the output list, the new list, you could always do that operation here and say you want to do you want to square the number, put it here, and then what we do here is we in the for loop we iterate through each element in the nums list, and then we append each of that using the square, and then we print it out. So if we do this, we get the essential same result. We could also put in if conditions here. and only filter the ones that we need, then print them out. Like the last time we want only the odd numbers, so we can filter those out and we have only 5 elements. So we can do that as well. We could also like have an if condition inside this and append only the ones we want. So we can do all that using a for loop. Why would we need to actually use a list? That is a question you might get in an interview. But list comprehensions are much more efficient than for loops. The reason is when we declare this, Python doesn't know how big the list is going to be. So the Python is going to like need to allocate a lot of memory up front. And then because it doesn't know, it needs to first allocate like 0 length, and then as things get appended, Python has to figure out if that has space there, or it has to create a new location in the memory and it has to add to it, which makes it very inefficient. So a better way would be to use list comprehensions. So this way is still going to work, but it's not memory efficient because Python like does not know how big this new list is going to be. So it's not allocating this. But while you do this, let's remove the if condition. I need to syntactically change that, but yeah. So if you do this, and then you do these two are similar. These are going to provide the similar results. But the problem with this is that when the new list gets assigned, Python does not know how big it's going to be, so it's going to be dynamically changing it whenever an append happens. It has to increase the memory. In this case, when this condition gets executed, new list gets memory as big as these statements get executed. So after the statements are executed, new list gets allocated that memory. So Python already knows how much memory needs to get allocated upfront. That way, Python does it much more efficiently. So these list comprehensions that we saw can be done using these for loops, but there are slightly better alternatives from a memory standpoint to do it. So that's another question your interviewer might ask. Those are map and filter. So if you don't remember what map and filter are, map and filter are functions that are built in that take in an iterable. So this is an iterable which is a list. So it can be an iterable that can be a list, or it can be a set, or it can be a dictionary. But any iterable can be the second variable. The first one is a function. It could also be a lambda function, or it could be a function that you define using the def command. But this first argument has to be a function. And what happens is each item that is on this list or iterable gets passed through this function and then is produced as a result using map. The difference between map and function is map, if there are 6 elements in the input, all 6 elements get passed through my function, and the resulting function, the resulting iterable has all the same number of elements as the input. So this has 6, this would have 6 as well. While in filter, it takes in a function as the first argument and an iterable as the second argument, which is in this case a list. In this case, the function for filter would always return a true or a false. And remember, any non-zero value in Python is also considered to be true. So if it provides the value true, then that element would be returned. So the filter, what it does is it filters out the number of elements in the input and only produces the output with the same list. But if the function returns a value true or false, I mean if the function returns a value true. So let's look at an example. There's probably a lot of information to process if you don't know what map or filter is. What map does is map function takes an iterable. So in this case, the iterable we're using is ages. So say we have ages 4, 5, 12, 7, and we want to see how old they'll be 3 years from now. So we want to see how old they'll be in 2025. So the current ages are these. So if I want to say new ages, then all I have to do is, instead of iterating through these using a for loop and doing each one of these one by one, I can use a map function, use this list as the second input. The first would be my function, and my function is defined here to return 3 years from the current age. And then if you want to print it, we can print a list of new ages. What this does is it goes through each of these elements from ages and then iterates that and creates a list out of it. And this should actually produce the same length as what input this is. So 1, 2, 3, 4, 5, 6, 7. So there are 7 ages here. We should come back with 7 output ages, but each of these ages would be 3 additional to the input ages. So the 4 would become a 7, a 5 would become 8, 32 would become a 35. So this is what the map function does. So map function, what it essentially does is it executes a function and provides an output of the input list or set, and then it produces it the same size. Let's try to do this with a set. I know there are no duplicates here, so it's not going to change the size of it. But if we do a set here, not sure if that's. So it produces the set, which is, as we know, the order might change in a set. So it produces a set with the same values as this, but it adds 3 to each of these values. So 4 becomes a 7, the 5 becomes 8, 32 becomes a 35, even though the order is different. The 12 becomes a 13, the 17 becomes 20, and so on. 18 becomes a 21, and the 24 becomes a 27. So if I want to print a list of this, I could do that. If you don't want to convert it into a list or a set, you just want to print new ages, it would only provide an iterator. So it's going to provide the memory location, the map object at this memory location. And if you want to try what type it is, that will tell you that this is a map class. So because we're using the map function here, so this is actually a map class. And to actually provide what all the values, you'll have to use the list function or the set function, or you could iterate through each of them. For I in new ages, and then you could print So that would essentially iterate through each of the ones in ages and then add 7 and then put it out here. So let's check this. So this becomes, so this set has 32 in it, that becomes 35, and so on. And if we use this as a dictionary, say if you want to say different people's ages, so Alan, Mike, this makes it a dictionary. Let's say C. Let's say we have only 4 elements to make it easier. So in this case, if you want to use this dictionary, and if you want to use a map function so that you can return certain things, then you will have to write a function that that is appropriate to this. So when we write the function, so this would return x plus 3 would not work, because we are going to get what we are actually providing is this. So we can actually say we could use it in different ways, but I think I don't want to complicate it right now. So let me move on. So this is another way we can use it, but let me go back to using a set or a list. And then we'll use it. So here what we're doing is we're printing them, but we're printing them one by one, and we're not converting this in new layers into a list. This is still a map class, and we're going through that map one by one and then providing it out. So this is another way of doing it. This is a very efficient way of doing it, which is very similar to the list comprehension that we do. From a memory standpoint, these two are very similar. It's much better than using an empty list and then appending it from a memory standpoint. So this is something which can be an alternative. But the reason why a lot of people prefer comprehensions is because it's easier to read. If you look at this sentence where we do a square for all these numbers, and we filter out the ones that are not. Here we would have to use a map function, and we might also have to use a filter function. So we might have to first use a filter function and then use the map function. So it might be harder to read, and it might, given that we have to using both map and filter, it might not be as efficient as using list comprehensions. So the map and filter are better than using the normal logic where we initialize a empty list or empty set and then go on and provide it. But that's not all. We could do that better using a map or a filter function. The even better way would be to use the comprehensions, and those are not only much easier to read. Sometimes when we have to do map and filter, those are done much more efficiently using the comprehensions. So we saw what map is. Let's quickly go back and check what filter is. Filter returns an iterator. The filter function returns an iterator where the items are filtered through a function, to test if the item is accepted or not. That is, when it is true, it returns the function, and it's not, it doesn't. So here we have a list of ages, and we want to see if anybody is 18 or over. So if they're 18 or over, they're an adult. So we want to filter those ages. So in that condition, we are creating a function called my function. We're providing each of these elements as input. And if somebody provides an input which is less than 18, then it provides false. So it doesn't consider that as an adult. 18 or over falls under the else condition, so it returns a true. So here, similar to the map function, we're using the filter function. And if we actually call this a list, and we can just print adults, what we would do is we use the filter function, we iterate through each of these ages, and each of these ages get passed through the my function, and the ones that get passed, that is in this case 18, 24 and 32 would be true. So in those cases, those would be passed out to this list, and then this list gets generated. That list can be printed out. Let's try this out. So this provides 18, 24 and 32. Say I just want to provide the ones that are less than 10. I mean, yeah, if you want to provide only the ones that are less than 10, so I say anything greater than or equal to return false, anything that's less, go ahead and return true. So I just want to like pull out the ones that are children. So this who are like single digits. So the ones that are 5 is the only one that's going to come out. So that's what this filter function would do. So we could accomplish the same thing using one line of code using this comprehension. So here what we do is say we want to return x for x in ages, but we don't want to return all of them. We want to filter them. So we use an if condition, and we say if x is less than 10, return those. In that way, we would return this 5. Let's say I don't want to run this. I just want to say I want to not only filter it out, but I also want to provide the square of this number. Then I can do that as well, which I would actually need a map function to do. I can do that here using this, and what that does is it returns out the value 5, and then it squares that and provides the list of that. So all this can be done in one line. For if you want to do that here, then we would actually want to this function can only do true or false. So I'll have to define another function, def sqrd of I, and I can return I squared. This way what I do is I do a map Let me do the map outside the filter, and then I can give in a function sqrd. So in this case, what I'm doing is I'm building out a list from my function that for the ones that are true, that is the ones that are less than 10, and then out of those I'm squaring that out using this function, using the map command, and then I can provide another list out of it. In this way, I can also do the same result as what this is doing, but I'm using a map function and a filter function to do it. So let's try if that really works. So yes, this does provide like first the filters are the ones that we want, and then the map function does the functionality that we want using this function. This function filters out what we want. So this can be done using the filter function as well, but you can see how the comprehension is much more efficient. Sometimes the interviewer might get into much more like tougher questions, asking, can you do lambda expressions directly in a list comprehension? So here, instead of doing this, what if we do a lambda function? It's not always a good idea. Let's, for today's session, I'm not going to get into the details of it, but let's not get too much bogged down. But as far as you know what a filter is, what a map is, and if you know how to use list comprehensions and why and when you would use those are sufficient for you to understand. If you understand how the map filter are better memory wise when compared to putting in an empty one and appending values, and if you understand how the comprehension of lists are even better than using the filters and maps, that would give you a huge edge with others when you're on the interview. I went through this very fast, but let's see when you would actually use a list comprehension. So now somebody does not even ask you those questions of difference between list and for loops and other things. So now they're just asking you to write a program. They're asking you to write any program. They have an input as a list, and then you want to get another list as an output. That should trigger your mind to think that this could be a case where I would use list comprehension. Let's consider an array of numbers. We just want to add 1 to those numbers when it's at the odd indices, and we want to add 2 to the number when it's at the even indices. So this is a simple program that they ask you to do. What your brain should think is, you have an array as the input and you want an array as an output. So this could probably be done much more efficiently using a list comprehension. Let's assume let's just do this logic using a for loop, and then we'll see if we can convert that into a list comprehension. So here we're defining a function called add 1 and 2, and then we are inputting the function takes nums as the input, which is a list, and it also takes the length of the input, and then we're going into each element one by one, and then we're checking if the index is actually an odd number or if it's an even number. If the index is an odd number, we add 1, and if it's an even number, we add 2. And then at the end of everything, we iterate through everything, and at the end of the for loop, we return the whole list that is stored in nums, because we are changing the value in nums directly. So in this case, if you see, we are starting with nums as let's for easy interpretation, let's just do 1 2 3 4 5 6 7 8, or let me do this, let's start from 0. So the indexes and the numbers are the same. So the 0th index has 0, third index has 3, 7th index has 7, and it totally has 8 elements. So if I'm starting with this, and what I want to do is for odd numbers, and we want to add 2 to the even numbers. So if I want to call this function, it needs 2 parameters, nums and length of numbers, which I'm not even sure why we need this. But yeah, that's the way we try to define this. So we want to add 1 and 2. So we are saying for each nums, it goes through each of them and then returns this. So we'll see what it prints out. So it actually returns out the same array but with modified values. So let's see what it does. So the first element is a 0, it adds 2 to it and becomes 2. The second element is a 1, it adds 1 to it and makes it 2. The third element is a 2, it's at the odd location, so it has to add 2, so it adds 2. And the fourth one is 3, it has to add 1, so it adds 1. So that in that way we get a 2 2 4 4 6 6 8 8. Looks neat, but yeah, this solution is not neat. And as we know, we are going into each of these elements and we're adding 1. So we're not really creating a new array. In this case, this uses the same array but edits the elements in place. Say we want to do this using list comprehension. So all we want to do is like replace this whole for loop with this list comprehension. And what the list comprehension does is, forget about this, this is what is the output. It goes through the same for loop. So the same thing, it goes through here. And here, this if condition, we just write it here. If I percentage 1, 2 is 1, that is its odd number, then it provides this element, else it provides this. So it adds num of I plus 1 whenever it's an odd number, else it adds num of I equal to 2. So whatever we're doing here, we write it here. Syntactically it's different, but essentially it does the same thing. So we can use list comprehension in this example. So whenever there's an input and there's an output, both are lists or both are sets, both are dictionaries, you should think of comprehension. List comprehension is the most commonly asked, so I'm going to focus there most of the time today. But there are other types of comprehensions, right? Dictionaries, sets, generators. So look at this. This is where we get a set, but we want to provide double the value of this. So whenever I get a set, say 312 as an input, but I want to provide a set or a list that is double that value. So in this example, I'm going to output a list. Each element doubles in value, or let's say instead of doubling in value, I'm going to add 2 to it, then we can do this using this. Say you don't want this to be a list, you want this to still be a set. I believe that can be done as well. All we have to do is go here and mark that as a set. So this goes through the set and then does this. So in this scenario, like each of these numbers are unique. So this 1 becomes a 3, 3 becomes a 5, and 2 becomes a 4. Notice that the order does not stay the same. That's how sets work in Python. Say if you're using another function where we want to say we want to produce I percentage 2. So for odd numbers it produces 1, and all even numbers it produces 0. In this case it will provide 1, 1 and 0. So it provides 2 1s and a 0. And because we are using it as a set, the set removes the duplicate values and you should get only 2 values, 0 and 1. So that's here. What will happen if we actually use it list here instead? Let's try that. Here, even though these two are duplicates, because the list does not remove the duplicates, we get all the 3 values back. This input could be a set like list as well, as we have done in earlier examples. So that should work as well. We could use a list to start with and then make it into a set. That's possible as well. So that's an iteration we can do. So we can do these with respect to sets. Let's say we create a class person. The person has 3 attributes like ID, name and age. So each person has 3 attributes. Now we have a dictionary where we have the first person with person ID is 1, Fred 26. 2, person ID is 2, name is Ria and age is 31. The dictionary has the third element 3. This is the name. The value is like this class person with the ID 3, name Syed, and the age is 23. So if you want to filter out the ones that are about 25, I can use a dictionary iteration for this. So what we do here is this is the ID. In this case, this and this ID are same, so we can use that. But essentially what we're doing is, let's go into the for loop. We are producing these 2 values when for ID comma person in person.items. So we're going through persons.items. So like we're iterating through this dictionary. It has 3 elements, 1, 2 and 3. We're iterating through that and we're getting ID, that is this value in ID, and we're getting person, that is we're getting this value in person, and we're having an if condition to say if age is greater than 25. So if I don't want to filter this, let's say I do this, then this is going to get me all the 3 elements. So 1, 2 and 3, and in the person object we have the memory location with person object, 1, person object 2, person object 3. So we have all three. Say I I want to filter only the ones where the person dot age is is um, is 25, or instead of this I want to do person dot name. So in this case, what I'm going to get is, instead of getting a, a memory location for the person object, um, I'm actually getting the object's attribute called name. So this person with ID 1 and person with ID 2, both of them satisfy the condition above 25. This is the only person who gets filtered out because that's less than 25. But for these two people, I returned the person comma name. So I'm going to get this. I could also get a list here with person comma name and person comma id dot id. So if I do this, then I still filter out these. But when I get the dictionary has the ID as the ID that comes out here. But I also get the name ID, and if I want to add the age, I can add that too. And this list becomes the value for each value in the dictionary. So you get the person's name, ID, and age in the same order in this list for the first value in the dictionary. And this list becomes the second value in the dictionary. So you can do that using comprehensions. We could do this for generators as well. Given the time constraints, I'm not going to go through that, but that's something you can easily understand after looking at these examples. We've gone through lists, we've gone through sets, we've gone through dictionaries here. Generators are very similar. There are a few lead code problems that we'll go through today to tell you like how certain lead code problems can be done using list comprehension, and those are pretty easy ways to do those. So I'm going to give you like 3 examples here, and then the remaining I'll just add in the description in the videos today. I'm not going to go through these in detail because I want you guys to take this as an exercise, try to solve this, and then if you have any questions, let me know in the comments below. I can definitely get back to you in a day or two. So the first one that we can actually solve using list comprehensions is we have a list that is provided. So this problem is called all possible subsets in lead code. They give us a list of distinct integers, and what they want is return all the possible subsets. The subsets are like, if you know what a subset of this is, it could be anything from empty set to it could be the full length. It could be a combination of just one of these, or a combination of 2 of these, or 3 of these. If it has 4, then it could be empty, all the variations of each one of them separately, each 2 of them combined with each other, then 3 of them combined with each other, and all 4 together. That would be 1. So in this example, because there are just 3, the output should have 1 empty, 1 with 1 of each, all combinations of 2 of each, and there's only one combination of 3 of all. So there can be only 1 with all 3 of them. So this is the full list. This is what, if they give you, if lead code tries to give this as input, you should get this as output. So again, this is a list. If they change this to say it's a set, it's very similar, but this is how the question was, so I'm going to keep it like that. So they provide a list, but they know that it's distinct integers, so it's similar to having a set, because we know that there are no duplicate elements because they say it's a distinct integers. We want to get all possible subsets and then put that into a whole list and then output that. So the way like this was done is we used list comprehension here, but the outer loop does not use list comprehension. What it does is it takes each element here. So essentially what we want to do is we want to get one with 0 and then one with each one of them, one with all two of them, and one with all three of them. So we could do a for loop, go through like the numbers increasing from 0, loop them one time, the numbers going to 1, then loop them until the length of the array, and then length 2, and then loop them twice. That could be a way to do it. But the way this was solved much better was it pulled out the first element. Let's say this is actually 1, 2, 3 to make it easy for us to understand. So it pulled out the first element in the first loop. So in the for loop, it pulled out the first element and it keeps 1 there. So let me take this off. So when this runs first, it has only 1, and then what this does is result is an empty list of list. What result what we do here when it's 1, so in the first iteration, like result is empty, and then num is 1. When we do result plus equal to, what it does is it adds another element here, then it adds 1 here, and then the next iteration what happens is result when it starts is already this, num is now 2. Given that nums is 1, 2, 3, so now nums becomes 2, but result has to append to this, so it starts with this and then appends the value it iterates through each value in result, so it iterates through this value and then appends a 2 to it, and then it iterates to this value and appends 2 to it, so then it becomes this, and then result then starts with this. When num is 3, what it does is it starts with this, and then it appends. It goes through each of these and appends a 3 to it. So it becomes 3, 1, 3, 2, 3, 1, 2, 3. Is that so? In this case, you see there's an empty. There's 1, 2, and 3. All the single digit ones. The 2-digit ones are 1, 2, 1, 3, and 2, 3. All 3 are covered. And the 3-digit ones 1, 2, 3 are covered. So in this case, what it does is it is in the last element num equal to 3, but the result set has all the elements that we want. This is equal to this. It's just not in the same order, and order does not matter according to lead code. So we can return this, and that should take care of this problem. So try this out. Try out this lead code problem. I'll provide you this question as well in the description so that you can reread the question with the examples. Another lead code question was that where you can use the functions that we learned today. The list comprehensions is here. So the problem from lead code is here. Given an array of numbers with 2n elements, so it has like 2, 4, 6, 8, or 0 elements. But what they want you to do is, the first n elements are x1, x2, x3, x4 until xn. The second n elements are y1, y2, y3, y4 until yn. They want you to return x1, y1, x2, y2, x3, y3, and so on until xn, yn. So they want you to split the array into half. So in this example, 2, 5, 1, 3, 4, 7, there are 6 elements. N is 3. They want you to put in the first element from here and the second element from the n plus 1 place, and then second element from here, the third element from here, and this from n plus 2th place, and then 1, and then here n plus 3rd place. So the third element and the n plus 3 element, the first element and the n plus 1 element, second element and the n plus 2 element, third element and the n plus 3 element, and so on. So we want you to do that. So this is something you can do. You can use a couple of for loops and iterate through them and do it. But you could also use a comprehension. Check this out and see which kind of approach you can use. If you're using post 3.2 and if you want to use reduce function, remember to use functools. That needs to be used. There's another one we'll go through, lead code. This is the last one for today. The other lead codes I'll provide in the description. But another one which has a lead code example is number of good pairs. Given an array of integer numbers, a pair ij is called a good if num of i's and num of is equal to num of j's and I is less than j. So they want you to provide like duplicates. So they want you to provide 1, 1, 1, 1 as 2 different duplicates, but they don't want you to provide 1, 1, like this element back. They just want to provide the one where I is less than j. Obviously they don't want you to count this as a duplicate of itself. So if there's 2, there's no other duplicate, don't count this, because when you iterate through, you want to see if anything after this is 2. So if you find 1, if you find 1 after this, then that's a good duplicate. So you provide 0, 1, 2, 3, 0, 3, that's a good pair. 0, 1, 2, 3, 4 is a good pair, but also 1, 0, 1, 2, 3, 4. 3 comma 4 is also a good pair where it's 1 comma 1, and here 3 comma 3 is also a good pair, so 1 0 1 2 comma 0 1 2 3 4 5. So 2 comma 5 is another good pair. This is what they want you to do. Again, this is a place where you can use list comprehension, and all they want you to do is not provide a list of all the good pairs, just say how many good pairs are there. So how many pairs of these are good pairs? So you just have to output the number of good pairs. So return the number of good pairs. You don't have to actually say which of these indexes have the good pairs. So all you have to do is that. So see how you can do this. That's all I wanted to cover for today. Thank you so much and have a great evening. Thank you. Bye.